So laying in front of me here on the table is a Kingroon KP3S Pro 3D printer. Unique style, cantilever, small footprint, of course small build plate, but this can be either an entry-level printer or a production printer. This company's been around for a long time. We're going to put this thing together coming up. I'm Roger, welcome to the loft above the shop, and I have yet another 3D printer. I'm going to put this one together today. This one here being the Kingroon Pro KP3S Pro, to be exact. FDM 3D printer, cantilever design, Cartesian type printer, similar to what's running behind me here, but a little bit different design. Small footprint, takes up small amount of space. It's excellent for the smaller projects. You're making something really big, this isn't the thing, but I think it's got a 180 millimeter square, maybe 200 millimeter square build plate. I'll have to get into the specs on it here. Kingroon did provide this to me to demonstrate, and that's what I'm going to do, and then I'm going to use the dickens out of it because I got a bunch of projects coming up. I've got all my 3D printers running right now, the ones behind me plus the ones in the other room, so I need another one. And this, not much assembly to this, and I didn't do an unboxing because there's not that many parts here. But I will kind of give you an overview of what you get. You get a filament roller holder, and I will be doing something different because I'm space constrained and I don't need something sitting off to the side, but I'll show you how this works. It works fine, there's just other options you can do. Comes with some sample filament, get a power cord, get a USB cable, you get some spare nozzles. Of course, you got a little bag of hardware. This is all that's required to put this together, these two little bags of hardware right here. Does give you a little bag of tools, SD card, micro SD card, and SD card reader. And of course, you have the Z-axis screw, nice protective tube. Get some cutter trimmers, get some PTFE tube, a little bit smaller than a regular Bowden tube, but it's basically just a guide. This is a direct drive extruder, not a Bowden extruder. So, get things moved around here and we'll put this thing together. Not too many steps to it. Okay, the first step, and I've got this turned, hopefully you can see it. There's a little bracket right here behind the C-axis stepper motor. You'll need the screws right here and a T-nut. Now, the screw goes through here and then the T-nut will go on with the rounded edge away from you. So you'll want the flat edge towards you because that's going to have to grab the extrusion when we put it in. And the easiest way to do this is with these ball drivers. You don't have to have one, but it just makes life a little easier. And you just want to start that on there. Don't tighten it up, just get the T-nut started on there and try not to drop the T-nut down the hole. You'll have to retrieve it. This is 2.5 M&Ms if you're keeping score. Well, there's two of these little guys to go in. Hey, once you have those in there and started, you want to turn it so the T-nuts are vertical because you're going to be putting the Z-axis and the X-axis gantry in there. So then that extrusion will just slide right over those T-nuts. It'll slide down into place like so. Don't let this just go crashing. Keep a hold of it. Now on the back side here, you'll see there's openings for two screws. That's where we'll be using screws from this. So there's not a whole lot of assembly to this. Pretty simple, pretty straightforward. Hardest part's getting the little Ziploc bag open. Let's tear the lid off though. There we go. And for this, if you're using a ball driver, it's 3 M&Ms. You want the longer screws here. And they will line up with some pre-tapped holes in the extrusion there. Just get them started, don't tighten them up yet. And I'm running these in until they just bottom out. I'm not tightening them up yet. So we're going to have to make sure we get everything square and straight and all that kind of good stuff. Now on the bottom, You'll see right here, there's openings for 2 screws. This is where the shorter ones will go. Yeah, I get this turned around so you can see that a little better. The lathe that's on its back. This is where those 2 screws go. They're right ahead of the little foot bumper. These are also 3 M&M head screws. Again, I'm just running them in until they bottom out. I don't want any stress on that when I tighten them. Now I'll take the stress off the gantry and I'll tighten these screws up. Here. And up here on the back. The way this is made, that should be pretty square. And then next we'll tighten up these 2 in the front, where the T-nuts are. Next will be the Z-axis rod. It's in this plastic tube right here. Protect it. Slip that down through the bearing at the top. And you can screw it through the carriage below. And it'll meet the stepper motor down there, and you got to make sure that goes all the way down into that coupling. I'll raise this up a little more so you can see a little better. There are 2 set screws here that will need to be tightened up. You want to make certain that that rod is bottomed out in that coupling. So I'm going to loosen these up just a little bit to make sure I'm bottomed out all the way. And I am, so I can tighten those up. The best way to do these so you don't get wonky with it is bring them both in snug and then go back and tighten it up tight. Otherwise you could end up with a little, get into the wrong type of the part of the thread and the rod won't run true. And you want to make sure these are good and snug but don't break anything. Oh, right there. You will have 2 extra screws. They do send some extra hardware just in case you get a bad thread or something. So you'll have a couple spare parts there, but it's not like you forgot something. So basically that is most of the assembly right there. Your machine's put together. Now we just have to get the eccentrics adjusted, and I'll show you what those are here. First I'll get all the plastic off of the front here. You'll notice on the build plate there's 4 clips, and you have to take those off so you can take that plastic coating off of the glass. This just peels off. And I clear off any little pieces of whatever. Make sure that's good and clean and flat and there's no burrs of anything sticking up, because that'll mess with your bed leveling. Get some little burrs of plastic here. I just scraped them off with my thumbnail, that's fine. But it would have been enough to mess with your leveling. It's just plastic, so it's not a big thing. You set your build plate back on. This is 200 millimeters square is your work area, actually by 200 millimeters high. You just put these 4 clips back on. Holds the glass in place. Next is belt tension. We're going to do the X axis here first. That's the one that runs this direction. There's a knob right down here in the end, and you can feel the belt underneath. And you want it tight, but you don't want it so tight that it stretches. But you don't want any droop in it. So you can turn this knob here until there's no droop, and it's just snug. As I said, don't make it so tight that it stretches. And it's kind of a subjective thing. You just got to kind of go by feel. Make sure that everything still moves smoothly. And once that's set, you can take your 2.5 M&M wrench there, or ball driver, and there's a little set screw right there you tighten up. and that'll hold it in place. You'll have the same thing on the y-axis. Knobs right here on the front, and mine's already pretty well preset. Tighten it up just a little bit. We're good there. Tighten that screw up. That's set. The thing you're going to want to check is if there's any play in this from side to side, and this does not have any. This is set very, very well right from the factory. You'll notice these two rollers right here. You should not be able to move them with just your finger, and I can't. There are nuts above those, and with a supplied wrench, if you have any give here, you can just turn those nuts, and they're what they call an eccentric nut, and they will put pressure against that wheel, which will push it against the rail, and it'll straighten you out. And you can also check on the other side. Of course, there's no eccentric nuts on this side. And I know you can't see down in there, but there's two wheels. Just make sure you can't just free spin them with your fingers. They should be snug against the rail, and they are. And while we're right here, there's a little bit of protective film you need to pull off of your LCD screen. One of the next things that's going to come up is bed leveling. And the way I like to do it with this type of printer is I will just turn this screw and lower my Z gantry down. You notice right here there's a very large headed screw. Hopefully you can see all this. Right here is the limit switch. I want to lower this until that limit switch just touches this, but I want to make sure that the hot end does not hit the bed. That's why I'm doing this manually by just turning it slowly with my fingers. You could also plug it in and just run it down, but you always have the possibility of crashing the hot end into the bed, damaging the bed. So what we're looking for here is for the limit switch to just make and that nozzle not hit the bed. Then we'll get on to the leveling here in a minute. This is adjustable. You can turn this up and down. I am pretty close there. So that makes before it hits the bed, so that's a good thing. So I'll raise that back up just a little bit. And we're pert near ready for power. As I said, there's very little assembly to this. This is an easy one. Okay, on the side of your printer right here, you'll see this red switch. Depending on where you're from, you need to set your voltage. I've got it set to 115 because we're in the US. Then I'm ready to plug a cord in right there. And I happen to have a cord handy. I'm not using the cord that came with it. I've got a cord I keep on this table all the time. And we'll power it up. And it beeps. And I'm going to have a hard time showing this screen. I can see that. So I can't get a better view of this. Okay, this is a touch screen, and it's not color, it's black and white. That's fine. We don't need color for this. So what we want to go to first here is called leveling. And it gives you, well, there's 4 quadrants and 5 points. So how about that? 5th point being in the center. So we want to start with point 1. And it will home itself first. Now what you're going to need is just a sheet of regular notebook paper, copy paper, that, just here's half a sheet of copy paper. So you want to put that under there, and then there's a little wheel underneath you can turn, because you want that to just touch the paper. And if it freewheels too much, you're going to have to make a limit switch adjustment. So I'm going to have to adjust the limit so that it bottoms out a little sooner. So to do that, I'm actually going to turn this off. Raise my Z-axis screw up. I'll turn this down just a turn or two. I'm going to leave my paper in there. I'm going to turn this back on. Let it boot back up. And home it. So I want to home Z. I'll turn this till I got a little play in there. Now I'm going to home all. The back arrow, go to the back arrow, go to leveling, go back to point 1. Take your notebook paper. And as you slide the paper under there should be just a little bit of resistance like there is on this one here right now. However, when you change another point, the first point you changed is going to change as well. So you're going to have to keep going around on this. Okay, we can go to point 3. And while I'm waiting for that to go to point 3, I will also mention that this is just a preliminary leveling. We'll do the final leveling after we preheat the bed because that always changes things. Things expand and contract. Well, I expand when they heat. So you'll be wanting to make some adjustments there too. And we'll go to point 4. And we'll go to point 5, which will put it in the middle. Of course, you can't make any adjustments there. Oh, that's getting pretty close. So now we'll go back to point 1. This is also called tramming, and tramming is actually the proper term for this, but everybody calls it bed leveling. So here we are back here. Now that is too tight because we messed with the other corner. Go to point 2. Point 3. Back to point 4. Go to point 5. That's a little loose there. We'll go back here to point 1. I'll go around one more time here and then we'll preheat the bed and check it. The more times you go around, the less adjustment you'll have to make each time. This does take some time, but if you want to have a good print, as I say, do it right the first time. As the old Murphy's Law is, why is there never time to do things right the first time, but always time to do it over? That applies. Close, but a little loose yet. It'll change when we preheat that bed. I'll hit the back button here, go back home. Preheat. And I'm going to heat the bed to 60 degrees C. E1 is your extruder. That's where you set your extruder temperature. The bed is where you set your bed temperature. The numbers will change as it heats up. And once your bed comes up to temperature, you can go back here and go back to leveling. We'll go back to point 1. Okay, back to point 1 here. We're heated up. Check this, and it is, of course, now it's too tight because the bed's hot. You want to be able to slide that paper in and out, but you want to feel a little bit of drag on it. If you got a lot of drag and you pull it out and you can't stick it back in, it's too close. So now we'll go to point 2. Good there. Go to 0.3. Now we're a little too tight here because I can't slide that paper in. And we'll go to 0.4. That one's a little bit loose. Doesn't take much. And we'll go to 0.5. Again, there's no adjustment here. It's just kind of a check. And it's a little loose there, but it'll pass. So next we need to get some filament loaded in here. Go back again. Go to the preheating. On the top one is for the extruder. We want to take that up to 200. Well, I guess you got to tap it every 10 degrees. And we'll let that preheat, and while that's preheating, I'll explain this tube. Okay, this tube, PTFE tube, there's a hole right here on top this just slips into. And over here is where it's going to meet. Now there's a hole there right above the filament runout sensor. Just turn around so you can see what I'm talking about here. This is the filament runout sensor. The filament will come in through the bottom, pass through here, will pass through this PTFE tube and into the extruder. This looks like it'll fit in that hole, but it doesn't. It just kind of comes up close to it. But as this pulls the filament, this will actually pull that tube down flush with that. Do not omit this tube because the filament will wear a groove in the top of your extruder entrance, and you don't want that at all. So I'll grab some filament here. I've got a scrap laying here. And one of the things that make easier to load filament, take your little cutters, cut the end at a sharp angle. So you got a sharp angle on there. It'll feed up to the bottom of this, and there should be a little light come on when it passes through. Like that. And you want to pass this through this tube. Just turned around here again so you can see what I'm doing. I'll pull this out so you can see what I'm talking about here. All right, now as you push this down in here, there's a little lever. You would just push. That'll allow you to slide the filament past the gear inside. You want to push that all the way down until it stops. And it should extrude a little bit of filament out the bottom. Yeah, I need to raise my Z height to do that. Be able to see what I'm doing there. We'll raise a Z. As you can see, I'm pushing out some filament. Hopefully you can see that. Yeah, must have been some white in there before. Okay, so we're loaded. We'll set this tube back down in there. Now next we need to get set up so we can do some files. I'll take you on the computer to do that. Okay, you're going to need to install Cura. That's my preferred slicer, and on the enclosed micro SD card is a file where you can install Cura, but it won't be the latest and greatest. So to get the latest and greatest, get in your favorite search engine, and mine here I'm going to use Google. Put Cura download into a search. It'll bring this up to Ultimaker's website. You can click on there. You can click on download for free. On the most current version as I'm shooting this video is 5.2.1. You click on that download and it'll give you your choices of whether you're using a Mac, Windows, or Linux. So you could take your pick there. I've already downloaded this, as you can see down here in the left corner. So I'm not going to download it again. So I'm just going to run that. And I already do have Cura on this computer, but it needed to be updated, so we're going to update it here. Let's bring up a little thing. I'll click on continue, and everybody reads the EULA, right? Yep. So then we'll just next, and we'll do install. Okay, and this will come up here. It says finish, and yes, we're going to go ahead and run it. So click OK there. This may come up. If it does, just click on allow access. And what's new? You can read that if you wish. Okay, here's Cura. Now, right now it's on one of my other printers. Yeah, it's on the Ender 3. So we want to add a printer. Click here, we'll add printer. And we're going to add a non-network printer. So we'll scroll down here until we find Kingroon KP3S is what you're going to have to pick, even though this is a Pro. We'll make a little change here, because this does have a 200 millimeter bed. So we'll click on that. I'm going to rename this on the end here. It's a Pro, so we got to have Pro on there. Click on Add. So this will come up. The only change you need to make here is right here. You have a 200 millimeter cube instead of a 180 millimeter cube. So just make these little changes. It will allow you to use your entire bed and height, Z-axis height. You don't have to do this, but it lets you operate with a full bed. Gantry height 200. Okay, it changed that itself. So we are good to go here. We'll click Next. Now we are ready to bring in a file. So something I'll point out here if you've never used Cura before, if this window right here happens to get over your work area, just hover your mouse over the top of it. You can move it around. You can also actually close it like this, and if you want it back, click this little arrow right here and it's right back there again. So, well, for right now, we'll take that out of the picture. So we need to bring in a file. We're going to do what they call a calibration cube. So it measures on X, Y, and Z on all three axes. And you can then measure after it prints, and everything should be 20 millimeter. The STL file's right here. I grabbed this off of Thingiverse. And there's also one on the micro SD card that came with the printer that's already sliced. But I'm going to show you how to do this here. So I'm going to bring this in. There's our cube. So now we want to do a couple of settings here. We don't need to set any adhesion here. It should adhere to the bed fine on its own. It does not need any support. I'm going to leave infill down here at, looks like it's about 17-18%, which is fine for a calibration cube. You're not going for strength or anything here. But you can't set that to 0 or the top won't print. It'll just fall into itself. It has to have something inside to hold it. So then from there, we just click Slice. And get the excess out of there so you can see. It's going to take 22 minutes. And if you have a micro SD card or an SD card in your computer, it will save to removable media or removable drive or something like that. Here it's save to disk because I don't have a SD card in right now. But I'll get that done and get a card in there, and then we'll get this back on the printer. Okay, before I turn this back on, there's a card slot right over here on the side. You put your SD card into. There's also a USB port there if you want to work this from your computer. The next thing you need to do is you need to clean the bed. And for that I use alcohol. By alcohol I mean this kind, not this kind. This is for later. And not for the printer. This is for the operator. So I'll just get a little piece of paper towel. If you could find the 99% or 90% or higher alcohol, that's even better. I was not able to find it the last time I was looking at 70% was the best I could get a hold of. Let's get you a little bit of alcohol on there. Wipe this down, you get rid of any fingerprints. Anything else you happen to get on there. It's important that your bed is clean. You're going to have adhesion problems. And there are other things you can use. Some people use Windex. Alcohol always worked best for me. I use that on all my glass beds. Now we'll turn this on. We've already leveled the bed. Did that in the previous steps. Let this thing boot up here. We'll preheat it. Hit preheat. Run the bed up to 60. And the extruder to 200. And we'll let that heat up. Okay, I've got this hooked back up and plugged in. I'm reheating the bed and the extruder, and I'm taking the bed to 60 and the extruder to 200. That's degrees centigrade. Okay, once everything's up to temperature, over here to the button that says printing, and of course I'm reading this upside down. Yeah, there's the one in English. XYZ cube. It'll ask you if you want to print it. You confirm it. Got a little filament running out of there. It'll go home first. If you've never done this before, that's called a purge line. It's printing right there. And of course, I'm not going to video the entire 20-some minutes of this print, but we'll leave this on there a little bit so you can kind of get an idea what it's doing. Okay, so while this is printing, I'll go over a couple little things here. So what can go wrong? Well, I'm kind of keeping an eye on this filament right here because I'm not using it off of a roll. This is just a scrap, so I'm making sure that it doesn't get tangled or anything. These filament holder spooling, I'll set it up when I do the next print on here, and I'll show you in detail how that goes. One thing you want to make sure of with your filament spools is when you take that end loose, don't let go of it. If you let that flip back and it spins around on the spool, you can very easily get what we call a cross wrap. And before I got into 3D printing, I was mostly familiar with getting a cross wrap on a spool because I'm a retired electrician and wire comes on spools. And if you get a cross wrap on a spool and you're halfway through a wire pull, it's all kinds of frustrating. You got to pull everything out and start over. If you end up with a cross wrap on a spool of filament, and you're 3/4 of the way through a print and it hits that cross wrap, it'll all of a sudden under extrude and it'll ruin the print. So you definitely want to keep hold of that, what I call the tag end. That's the loose end. And most spools have a little place in there where you can take that tag end and weave it back through. There's also little spool clips you can get off Thingiverse and print your own little clips. Clip that tag end down so it doesn't go wild and you won't end up with a wrap. So that's one thing that can go wrong, and it's something that's very, very easy to avoid. Another thing I hear of from a lot of viewers is my prints won't stick. You know, okay, this is a glass bed, several of these others are glass bed. One of the beds is a magnetic PEI. You have different types of beds. Your bed needs to be clean. You need to set it to the right temperature for the type of filament you are using. I could have used 50 degrees C bed temperature on here. However, the ambient temperature in this room up here is only in the low 60s. If you are at room temperature and like in your house where it's like 72, 74 degrees, 50 degrees C bed temperature would probably be fine unless you got cold drafts or you've got it by a window or something like that. So bed temperature can make a difference on how well your prints stick. Here I put nothing on this bed. It just cleaned it off with the alcohol as you saw, and everything's sticking just fine. Some people use Aquanet hairspray. If I do have a problem with certain filaments sticking, I will use these little purple glue sticks. This is from Office Depot. Same with the Elmer's glue sticks. Rub it on, don't go overboard with it and make a big layer of it on there, or you'll mess up with your first layer height. Just put a light coating on, and then it's good for 3, 4, 5 prints before you need to clean it off again. And it comes right off with water. You just take your bed off and put it in the sink and wash it off with water. And then follow that up with a little alcohol wipe, and you're good to go again. Okay, we're getting through there. We're about 3/4 of the way through that print, and the screen right there will tell you your progress, and it says it's at 74%, so I was pretty close when I said 2/3, 3/4. Well, it's close. And we'll measure this when I take it off. It should be 20 millimeters each direction. That tells you if your steps are correct, and they can be adjusted within Cura or in Marlin. We won't get into that, especially if you're a beginner. You just get confused. But it's a good little test, calibration test, to see how well the printer comes from the factory. Okay, so what do I do with these? This is a nice little small format printer for making small parts. So what kind of small parts? Well, some people make little game pieces and etc. I make a lot of special parts. This happens to be for Ortura LaserMaster 3. It's a mount for it, and then you can put risers on it. This is a riser for another style laser that I designed. We have kind of a running joke around here. If you've watched any of my videos from down in the shop, I'm a big DeWalt guy. I've got like DeWalt everything. And so got key tags here that I make. And these are kind of a little gag thing. It's a running joke with my family and friends. This would be a spare key for D-Shed, D-Shop, D-House, D-Garage. And I put rings on these, and we have a cabinet we keep spare keys in in case somebody loses a key, or you need one in a hurry, or the wife needs one to get into the shop and forgets the code or whatever on the door. So we do have a coded keypad, but you can also unlock it with a key. So it's a couple of things that you can make, different types of decorations and doodads and gizmos. And on the on the printer back here in the corner, I'm actually making a spool holder for this printer. It's going to mount up on here on top so that the spool feeds this direction from the top. It's a spool holder that comes with it. Will sit off to the side on some little rollers, and it works fine. It's just because of where I'm going to put this, I don't have the real estate over there for that, so I need to be able to have the spool on top. So what am I going to do about the filament sensor, because it's clear down there? Well, don't know yet. Going to make some kind of bracket, hopefully, and either relocate it up here or just put a dummy piece of filament in and operate this without a filament runout sensor. I did it for quite a while without filament runout, so most of these Ender 3s back here don't have it. I just watch it, I don't run out of filament, and keep an eye on that. I've got a pretty good idea now. I've done this long enough to know how much filament's on a spool, whether it's going to make that part or not. So how quiet is this? Well, it's very quiet. It's quieter than any of my other printers. Of course, it is smaller, it has smaller fans, but I mean, it's no louder than a rabbit's fart. So yeah, you could have this in a room where I don't know if I want to have it on my nightstand, but you could have this in a room in the house and it would be fine. It wouldn't distract anybody. The early 3D printers made a lot of noise. Every time a stepper motor moved, it would make a squeal. So that was a big improvement when they came out with the silent drivers. But yes, this operates very, very quietly. And as I said, it has a very small footprint to it. And it's actually going to reside back here behind these other printers, because I've got a place that this will actually fit. A handy little tool to have, and we're going to be using it here shortly, is a digital caliper. And this does it in millimeters and SAE, and I can actually do fractions of an inch with this one too. It's made by Fastener Cal, and I probably bought this on Amazon who knows how long ago. You can also buy inexpensive ones at places like Harbor Freight. However, if you buy a Harbor Freight digital caliper, either take the battery out when you close the case, or do not close the case. Because when you close the case, it turns the caliper on, runs battery down. And there's a lot of reviews on that all over the place about, yeah, the caliper is accurate, it works well. However, that's just a terrible design right there. That, and every time you would move the caliper, or if you would bump it, it would turn it on. And eventually your battery runs down in a hurry. And they're little button batteries, they're not expensive, but the problem is you go to use your caliper and you got a dead battery. And if you don't have another one, you got a problem. So when this here gets done, we'll do a little bit of measuring, but this is a handy thing to have. It's good for checking your models and your prints. If you've designed something in Tinkercad or AutoCAD or wherever you're designing your models at, or if you downloaded something from Thingiverse and it needs to be, let's say, 15 millimeter, and you print it and it comes out 16 millimeter or 14 millimeter, you need to make some adjustments and find out what you did wrong. This is an excellent way to measure that. And it not only measures inside and outside, you can also measure depth. So it measures things 3 different directions. Handy tool to have. You don't need to buy a Starrett and get real high end with it. I mean, you're not building a space shuttle here. You're just doing some 3D models and hey, we're done here. We can do some measuring. Let me get that off the bed and we'll see how accurate we are. That's stuck. I gotta let that cool off. This is something else if you're new to this. Let your bed cool off and that print should come right off of there. Don't be trying to force it off, you'll break something, and don't be trying to gouge something down. They do make scrapers, and I have several up back here for using on other printers. But if you let it cool off, it'll pop right off of there. Okay, let it cool off, so let it cool off for a few minutes there, and we've got it popped off. So what's a calibration cube? This is a little cube here. You see there's an X there, there's a Z there, and a Y there. Why? That's because you can measure how accurate your printer is by measuring across these different axes. Axis, different Cartesian directions. So we'll turn the thing on here, and we'll do Z first. Z is up and down, also called Z. Although I know somebody called Zed, and he doesn't like it when people use that. So we are at 20.31 on Z. Yeah, I just pissed that off. Okay, Y. Why not? 19.99. X marks the spot. 19.96. When they're that close, I don't mess with it. That is so close to being perfect, it's not worth starting to mess around with on your E-steps. So yes, this is very accurate right out of the box. Okay, the next thing I want to show here is how to change filament and how the actual filament holder works that comes with it. That's these little guys right here with the rollers. So you're going to get yourself a box of filament, and don't buy some off-brand weird company filament because you're going to have problems. I can almost guarantee it. This is from Kingroon. This is what they call a rainbow filament. As you can see there's different colors through there. One of the other printers running behind me has some multicolor silk filament in it. You'll notice this is vacuum sealed. And you'll want to make sure that you do not leave your spools of filament out where they can be absorbing water from humidity, because you will end up with ruined prints, as PLA and many other types of plastics, especially nylon, will absorb water out of the air, and then as you go to print it at 200 degrees C, that water flashes to steam, and you'll end up with bubbles and weird things in your print, and you'll think you're under extruding, and it's not the case. It's because you let your filament get wet. So you need to keep it someplace dry. I have a box in here that I keep with desiccant in it to keep the filament dry. So the way this works, let me get rid of my trash here. Your spool will set on these rollers like this, and it will feed this direction into the printer. So what I need to do first is remove the filament that's in there. So we'll go back here to home, and we'll go back to preheat here, and we'll heat the extruder up to 200 so I can pull this filament out. So we'll let that heat back up, and I'll pull this little scrap of filament out, and we'll load this in. Now what I was talking about earlier was what they call the tag end. You'll see right here where it's looped through these little holes, that's called the tag end, or the loose end. So I'll be taking this off. I'm not going to pull the last one out until I'm ready. Now, because of the way the filament feeds into this from the bottom, I want this wrap coming off the bottom. Not like when you put toilet paper on the holder and have the wrap coming off the top. Here we're going to have it coming off the bottom. And if you're running your toilet paper off the bottom, you're doing it backwards. Yeah, I just started a debate there, I'll bet. So we'll let that sit there for a couple minutes and let this heat up. Now we're up to temperature. Okay, so I could grab my filament down here at the bottom, pull the little lever back at the top, and just pull it out. Just like that. Now I'll take my new filament here, keeping close hold on that. Don't let that end go because it'll wrap back around. So you see it's all wonky there on the end. I'll cut a sharp angle on that, like so. Feed it up through the filament sensor. Feed it through my tube. And coming out the other side there. Pull a little extra out. Set that down on the hole there. Pull the lever back again. Run that all the way down until it kind of squishes out the end, and it is. Push the PTFE tube back down. Trying to get some of your slack out of there. You don't have to worry about a cross wrap now unless you let it come off the spool. Don't do that. So now, all I need to do is heat my bed back up. Take that back up to 60. Clean my old filament off of there. This is called the purge run. It runs along the edge. One thing I did notice is it runs its purge over the top of my little clip here. So what I'm going to do is take that clip and probably put it up here in the front, so I'm not running into that again over here. I did notice that on that first print, and then I'll get a little bit of alcohol and clean that again since I just touched it. Get rid of all them fingerprints I just put on there and anything from the previous print. And with that bed heating up, that alcohol will evaporate quickly. And our bed is almost up to temperature. We'll go back, we'll go to printing. And I will print one of these files that I don't know what it is because it's in Chinese, so I guess we'll find out. And we're going to print that model. I don't know what it is, but we're going to print it. So it'll wait just a minute. Yeah, it's getting close here. It'll come to its home position first. I don't need to re-level here because I haven't moved the printer or done anything weird with it. It'll run its little purge down the side. If you move your printer and carry it around or transport it or something, they're not really made to be mobile machines. You're definitely going to have to re-level the bed, or at least check your bed level if you move it. This will give you a little bit better of an overview of how that spool holder works on the Kingroon here. And like I say, it sits off to the side. I'm going to make something to make it mount to the top, and I think I've got a way figured out. I'll have to 3D print a couple parts to still allow to be able to use that filament sensor where it is, It'll just be a little bit different route for the filament. I don't have the real estate for where I'm going to put this to have that running off to the side like that. But otherwise, if you've got the room for it, it works just fine. Kind of get you in close a little bit here on this is that mystery file. I didn't know what it was, but it looks like it's printing some kind of little guy. Kind of cool looking, actually. I'm going to have to run all through all the prints on here that are in Chinese, since I don't know what they are, and find out what they do. Kind of a cute little guy there. We'll let him cool off a little bit. Yeah, I'll let him cool off a little bit, and we'll pop it off the plate, and we'll see what the next file is. Kind of interesting when you don't know what they are. So, there he is. Now, get this thing preheated again, and we'll find out what the next file is. So, several days later, still have the Kingroon printer here, and was delayed here on what I could do, and I have made some modifications to it, as you can see, and I'll get into those in another video. But briefly, because of where I want to make this live, which is going to be back here in the corner, behind and up above my other printers back here, I did not have the space to have the spool holder out here, so I 3D printed a spool holder for the top. This is highly customized. I started out with a file from Thingiverse and then just started modifying things. The filament runout sensor, I have run some prints here. It does work. It's not the ideal place because now you've got quite the route for the filament, but in the prints I've run so far, I've had no problems with it. But overall, this printer, it just works. It's right out of the box. It works fine. I've had no issues with it whatsoever on the test prints I've done here, and there's one that isn't here that I used to prototype something else I'm working on down in the shop. So with that said, if you'd like to get one of these, I will put a link in the description. And again, Kingroon did provide this to me to test and demonstrate, which I've done. It's going to be a handy little printer. It's got a small footprint. It's going to be great for small parts. So if you got anything out of this, appreciate getting a thumbs up. Always helps the channel, and you'll see more on this coming up here in the future this winter. Thanks for watching. We'll see you in the next one.